जी स्क्रीन सबको विजिबल है?
Yes, sir.
Yes, sir.
Yes, sir.
जी ये एक न्यूमेरिकल था जो हमने सॉल्व नहीं किया था, so let's solve it. So here you see some data which is given. Water heating collector with an aperture area of 4.10 meters square is tested by the ASHRAE method with beam radiation nearly normal to the plane of the collector. The following information comes from the test. So this is what has been measured during that test. Right, so let me draw the experimental setup from which this measured data was obtained. Here, so there was a temperature measuring instrument which was measuring the ambient temperature, which is 10 degrees Celsius. First test was performed with TI, the inlet fluid temperature was maintained at 18.2 degrees Celsius. And there was solar radiation, which was exactly normal to the surface of this solar collector. The area of this collector is given, total, which area? Aperture area, which is 4.1 meters square. The radiation which was measured for this test when the inlet fluid temperature was 18.2. So this radiation, available radiation, was measured with the help of pyranometer, and this pyranometer is placed on the plane of this solar collector. This pyranometer is not placed on horizontal surface. It is exactly on the plane of the solar collector. So it means it is measuring this radiation at this beta, if it is sloped at some angle. So this G, which is measured on the plane of the solar collector, is 864 watts per meter square at that instant. Okay, TI is 18.2, ambient temperature is 10. Then QU is measured. How QU would have been measured? Actually, this collector would have been fed with this fluid at a certain mass flow rate. And actually, we are measuring TO, outlet fluid temperature. So then this QU was measured using this simple equation, m dot Cp into delta T, where delta T is TFO minus TFI. So this QU is experimentally measured using that experimental setup. And that was measured to be 9.05 megajoules per hour. It means for the whole hour, these conditions were constant. It means for that one particular hour, TI was fixed, TA was fixed, this G was fixed, and TO was calculated, right? So for the whole hour, the total amount of energy which was measured or gained by that fluid from that solar collector is 9.05 megajoules per hour. So the same test, a similar test is performed again, but now the inlet temperature is very high, 84.1. So here TI is increased to 84.1 degrees Celsius. Now, of course, now fluid is entering at a very high temperature, and its temperature will further increase within this solar collector. So in the whole solar collector, this fluid which is flowing through the solar collector, the temperature will be very high. In the second case, right, here TP will definitely be greater than 84.1. In the first case, the fluid temperature was very low, so this would have been increasing from 18 to maybe 10 degrees Celsius or 5 degrees Celsius. So here, in the first case, TP would have been very low compared to the second case when inlet fluid temperature is very high. So in the second case, the losses to the ambient U delta T in this case would be much larger compared to this case. Right, in the first case, plate temperature was low. In the second case, plate temperature would be very high because Ti is very high. So that's why, and GT, the available radiation is 894 in the second test. And the QU is measured to be only 1.98 megajoules per hour. Although available radiation is increased, but this U delta T term, the losses would be very high, right? So using this experimental setup, we are not measuring these losses. We are only measuring the heat gain, right? And that is shown here, 1.98. Now using this experimental data, just an experimental data from some solar collector, it could be flat plate, concentrator type, evacuated tube type, or any type of solar collector. This data was derived experimentally. Now we are required to find out what are FR tau alpha and FRUL, right? The theory we have already discussed, the meaning of these terms that represents the intercept or the optical losses, and this term represents the thermal losses. So with the help of this data, we can find out these two terms, the loss term, heat loss term, and the intercept efficiency or the optical efficiency or optical losses, in other words. Right. So from this data, we can plot it on the diagram which we have studied or used, which are normally used worldwide to represent the thermal performance of any solar collector is efficiency versus this heat loss term, Ti minus, for in ASHRAE method, the x-axis is TFI minus Ta divided by G. In European method, they use TFM, the mean fluid temperature, means To plus Ti divided by 2, the average temperature. So now on this graph, we can plot this data. How we can, because on one side we have efficiency, on the other side we have this term TFI minus Ta divided by G. So first of all, for the first case, this is first case or first data set. That is the second measured data set. For the first one, we can find out the efficiency. The thermal efficiency of a solar collector is given by heat gain divided by collector area into solar radiation on the tilted surface, GT. So the measured data tells us that QU is 9.05 into 10 to the power, because it is megajoules, so 10 to the power 6 joules per hour. So we need to convert this hour into seconds. So that's why divided by 3600, because this G is given in watts, joules per second. So that's why this should be in joules per second also. Okay. So that is 9.05 into 10 to the power 6, that is divided by. Okay, ये megajoules per hour है. I was initially thinking it is megajoules. So it means this is the instantaneous heat gain that fluid is entering. at this temperature, TFI, and leaving at a certain temperature, TO, right? And you wait for some time until all this TO is not changing, because TI will increase to TO. So we shall wait maybe 10 minutes or 15 minutes, and then you calculate this TO when it is not changing, or this measured value of TO when everything gets settled or steady state conditions are achieved. Then we calculate this QU with the help of this equation. Here m dot is not given. This fluid would have been entering with certain m dot. So using that m dot Cp delta T, this value is calculated. So it is given in megajoules per hour. So that is actually watts. Okay, so that is QU. Now we have to divide by area. Area is given here. It's not absorber area, here aperture area. Right. So you may divide it with absorber area. So you will get a different value of efficiency. Because when this area is decreased, absorber area will be less than the aperture area. So you will get a higher number of this efficiency. That's why it is very important to mention that how the efficiency is calculated on the basis of which area, absorber, aperture, or gross area. So here, aperture area is given 4.1 meter square multiplied by GT. In first case, it is 864. Right. So this efficiency comes out to be 0.71. So here you have efficiency axis starting from 0, that is 0.2, 0.4, 0.6, 0.8. Right. So this one is somewhere here, 0.71. It is 0.8. So we can plot it on a graph. So 0.71, so it is somewhere here. This is the efficiency corresponding to what is Ti minus Ta divided by G, the x-axis. So x-axis is Ti minus Ta divided by G. So Ti was 18.2 minus 10 divided by 864. So this is 0.0095, 0.0095 meter square Celsius divided by watts, right? Because here you have watts per meter square. So this is, for example, now you have to show it on this program. This is 0.01, 0.02, and so on. Now, for example, this is 0.1. So 0.0095 somewhere here, corresponding to this one. This is our data from first measurement. That is something which we have shown. Now the same collector, but different TFI, then this is the measured data. So we will calculate this efficiency again. For the second case, this was the first case. Similarly for the second case. So now efficiency, I will write directly the answer of QU divided by ACGT for the second case, and that is only 0.15. For the first case, when this TFI minus TA was very small, here TI minus TA was only 8 degree, but here TI minus TA is 74 degrees. So that's why temperature, this U delta T term is very high, will be very high, and that's why the heat gain is very small for this G, the available radiation. So that comes out to be 0.15. And corresponding to this, what was the heat loss parameter? Ti minus Ta divided by G, and that is 0.083. So this is 0.1. So somewhere here, if you plot it on a graph, that is 0.083, 0.01, 0.02, 3, 4, 5, 6, 7, 8. So 83 somewhere here. And corresponding to this, the efficiency is only 0.15. This is 0.2, this is 0, so 0.15, somewhere here. So that is the second point. Now we do not have intermediate points, so now we can join it with a straight line. It's my iterator. So ideally we would like to have these intermediate points so that we can have exact curve for this solar collector, exact efficiency curve of this solar collector. But based on these two data points here, we have shown its performance on this diagram of efficiency versus Ti minus Ta divided by G term. Right, so we have seen this diagram before. So now we need to calculate the slope, because this term represents the slope of this efficiency equation. So it means this value, this slope. And here now we have a straight line for which two data points are given for this straight line. So this is, for example, you may say this is x1, y1, and this is x2, y2. So now with the help of this, how we can find slope of this line? Slope is given as y2 minus y1 divided by x2 minus x1. So what is x1? This TFI minus TA, this is x1. X1 is 0.0095, y1 is 0.71. Similarly, x2 is 0.083 and y2 is 0.15. So put it here, and that will be slope, and slope represents the heat loss. Slope is dropping, so that will come out with a negative sign. The final answer will be with negative sign because slope is decreasing. So that is 7.62 with a negative sign. And slope represents F R UL. थ्योरी दोबारा से रिवाइज करें, चलो लास्ट लेक्चर्स में हम कवर कर चुके हैं. You will note that this term represents the slope, FRUL. So now we know the slope of this line, which is FRUL, that is to be calculated. इसकी units क्या होंगे? Watts per meter per degree Celsius. FR is unitless. That is a factor which we have already discussed in theory. Now the second term is to find out this FR tau alpha, that represents the intercept of this line. Intercept means if we extend this curve further until it touches this y-axis. So this point represents this FR tau alpha. And what is that point? When the Ti minus Ta is equal to 0. This point. Ti minus Ta this is exactly 0. It means there will be no heat loss. So only optical losses. So how to calculate this intercept from the equation of this straight line. So what is the equation of straight line? Let me erase some. Okay, so the equation of straight line is y is equal to mx plus c. So in this equation, that term represents the intercept and that term represents slope, which in our case is negative. So how much it was? Minus 7.6. So now we can find out this intercept for any given y and x value. So use x1, y1 or x2, y2. Right. So for example, I use x1, y1 here. So this is y1, this is x1, y1 is equal to mx1 plus c. And that intercept is to be calculated. And that intercept is actually fr tau alpha. So y1 is 0.71 is equal to m slope, which is minus 7.62 multiplied by x1 is 0.0095, x1 0.0095 plus c. So from here we can find out this intercept, which is f r tau alpha. So that comes out to be 0.78. Right. So from that measured data, now we have calculated these two terms, how the heat is lost in that collector, what is the slope of that heat loss, and what is the intercept or the maximum possible efficiency of that solar collector whose experimental data was given. But to get a more accurate curve, we should have intermediate points. And we get more accurate curve. Maybe intermediate point would have been like this one. So we can have the exact curvature of this curve. Right. Any question? So now with the help of this, now with this example, you can understand the theory which we have already covered regarding these terms FR tau alpha, FR UL, and how to relate the theoretical analysis with the experimental analysis or experimental data. All right. So now I will discuss the assignment which I have just shared with you. हमने assignments भी conduct करनी at least 4. तो assignment आप पहले submit करा चुके हैं. This will be assignment 2 और जो आपका term project है that will be equivalent to 2 assignments. ठीक है, so इस तरह ये 4 assignments complete हो जाएंगे, which is made necessary now. Okay, हर subject में 4 assignments और 6 quizzes are must. इसलिए ये assignment 2, that assignment which you will solve, इस assignment में आपकी जो ये assignment will be very helpful for the preparation of the final exam. Final exam, maybe you will get a similar kind of question, a design problem in which you have to solve it starting from chapter 1 till chapter 4. सो इस क्वेश्चन को मैंने फ्रेम ऐसे ही किया, दैट इज सोलर एयर हीटर, जिसमें ये बीटा स्लोप गिवन है, स्लोप गिवन है, और अवेलेबल रेडिएशन मींस G, watts per meter square, on that day, January 10, between just 2 to 3 p.m. solar time. Isotropic diffuse model use करना है। ये जो given data है, इसकी help से of course you can find out the incident angle of radiation for that latitude. Sorry, latitude here 32 degree, and for that beta, and for that del declination, and for that omega. And then using isotropic diffuse model, you have to find out first beam, diffuse, and ground reflected parts of this available radiation, total global radiation. Then you will calculate the tau alpha products, because ground reflectance is given, absorptance of the plate at normal incidence is given, glass cover the data given, like its thickness, its refractive index is given, extinction coefficient given. So with the help of this glass data, you will be able to calculate TAWs for every term, whether it is beam, diffuse, and ground reflected, and then you will have to calculate alpha and then tau alpha, and then you will calculate the absorbed radiation S, and then you will solve the rest, the thermal part, the plate to cover space. It's a air heater, right? So air heater कौन सा single cover type? Single cover type means this is glass cover and this is absorber plate, or single cover means only one glass cover, one absorber plate, and air is flowing through that space. So इससे related ये data यहाँ पे. So with the help of this, you will solve this whole problem to find out, find क्या करना है इसमें, calculate the outlet temperature, Ti is given, TO is to be calculated, and of course efficiency भी calculate करनी है, means you have to calculate QU, with the help of which we can find out the efficiency of this solar collector. ठीक है, so ये सारा given data. अब इसमें जो instructions हैं, it is very important. Last date 5th of January है, Google Classroom में ही submit करनी है. This is important point. So in every तो नहीं है, just one numerical problem है, replace at least any one appropriate numerical value with your 4th and 5th number of your CNIC. So वो अब आपने खुद से choose करना है appropriately कौन सा number है इस पूरे given data में, which you can replace with your CNIC 5th and 6th digit, means 2 digit, जिसको आपने यहाँ कहीं ना कहीं यूटिलाइज करना है इस पूरे प्रॉब्लम में. हो सकता है इस प्रॉब्लम में कोई कुछ डाटा मिसिंग हो, वो आप खुद से उसको एज्यूम करेंगे. Assume appropriate values for any missing data or information. Assignment must be handwritten, submit electronically as single PDF file, image or word file में नहीं करना. 0 marks for the same handwriting. File size कोशिश करें बहुत ज़्यादा exceed ना करें, और आप इस तरह फाइल को नेम करते हैं. So we shall discuss the similar kind of problem, not the problem but the overall procedure of solving such problem, because exam में भी आपको similar type का question आएगा, but that will be much more detailed and confusing. उसमें data इतना explicit form में नहीं given होगा, that will be something in a different way. तो वो भी हम एक्सरसाइज करेंगे नेक्स्ट 2 वीक्स में किसी भी टाइम के ऊपर. तो फर्स्ट ऑफ ऑल आई वांट लाइक टू सी कि आप इसको खुद से सॉल्व कर पाते हैं या नहीं. सो एवरीवन विल गेट अ डिफरेंट आंसर, राइट, बिकॉज यू विल रिप्लेस एनी वन वैल्यू. अब आपने मास फ्लो रेट को नहीं करना, बिकॉज यहाँ पर अब यहाँ 0.056 को अगर अपने CNIC नंबर के ये 2 डिजिट्स रिप्लेस करेंगे तो ऑफकोर्स सबके आंसर सेम आएंगे, यहाँ कोई इतना ह्यूज डिफरेंस नहीं है सेकंड और थर्ड डेसिमल में. So you have to utilize somewhere here or here or here or this one, right? Or maybe nahi ye rock. So this is something you will decide by yourself. I have written कि आपने appropriately choose करना है. So appropriate means that it should make a good sense when you're replacing any number with your registration CNIC number. Okay, ji, so that will be your assignment 2.